final video we're going to talk about the discharge time of a cell. So if we have a, let's see, so we have our battery or cell connected up to a certain resistance. Say our cell is 1.5 volts and our resistor is 1.5 ohms. Then from V equals IR, I equals V over R, we can have a current of 1 amp here. Now it might be interesting, you want to know how long your battery is going to last, and you can investigate that experimentally by plotting the voltage across the terminals. V, that's the terminal voltage, against the discharge time, the time it takes for the battery to for the battery's terminal voltage to drop dramatically. And what you'll find is you get this type of graph. You'll start with the terminal voltage, the maximum 1.5. There'll be a sudden drop in the beginning, and it will keep changing with time like this, and then suddenly it will drop down. Maybe that's a bit too dramatic. Something like that. Now, however, if I was to replace this with another resistance of, say, 0.75 ohms, then I'd have double the current. This would be for a current of 1 amp, and I'd have a current of 2 amps now if I halve the resistance. What you would see now is the discharge curve looking like this. It would discharge a lot quicker because it would draw a lot more current per unit time. However, if I was to increase the resistance to, say, 3 ohms, halving the current, then the discharge time graph would be more prolonged. So the features of this graph which you have to know is that there's a sudden drop in the beginning, and then roughly a flat curve, and then a sudden dip at the end. And the factor that can affect the discharge time is the higher the current, the shorter the discharge time. And the reason why we have a shorter discharge time is, or the reason why we have a change in the terminal voltage rather, is due to an increase in the internal resistance in the cell over time.